already learned the multiplication of matrices. I think you understood it. Now we have to go through division. But in matrices there is no division. But there is another method for division. Instead of division, we are going to find the inverse of a matrix. It's for a number. Let it be 4. A number 4, we know it has a reciprocal. The reciprocal for 4 is 1 over 4. Isn't it? In the same way, for a matrix A, the inverse can be written as, this can also be written as 4 raised to negative 1. 4 to the power of negative 1. Similarly, a matrix A is taken, its reciprocal is A to the power of negative 1. If you want to multiply a number is 4, if you want to, we can suppose if this number can be multiplied by another number, but it is not, a rule is there which is not allowing it to divide. The same case is for matrix. And then, I already told you, in matrix there is no division. But see, this number, this is, if we take a number, you can understand it more fast than the other one. If I want to multiply here with anything, we can do it. Suppose I want to divide this 4 by, we can take a big number, so it will be, let it be 12. If I want to divide this 12 by 2, it's if it is not allowed, we know that it's instead of dividing this 12 by 2, we can write it 12 into 1 over 2, isn't it? It's a multiplication, isn't it? Instead of this 1 by 2, we can take it as 12 into 1 by 2, we know it is 0.5. So, instead of dividing, we are multiplying. In matrices, there is no division. So, instead of dividing, we are going to take the reciprocal and then we will multiply it. It is allowed. For a number, if it is not allowed to divide it by another number, we can take the reciprocal for this number, which is 12 is to be divided by 2. For this number, we are going to take the reciprocal and we will multiply it. The same thing, the result will be same thing. This is the case with the matrices. So, so if you want to divide a matrix B by A, and there is no division, so what we are going to do is we will take the inverse of a matrix and then we will, we can multiply it. First we should find the inverse. So inverse of a matrix is important. Why? Because there is no division in for matrices. But for numbers, if we take a number, we know it, isn't it? To find the inverse of a matrix, we must know the determinant and some different kinds of matrices are there. You should know everything. So, I think you didn't learn, you told me you didn't learn these things, isn't it? So, to find, first we can see, I'm going to write a matrix with the 0, 0, 0, 0. What do we call this one? This is a 0 matrix. This is a 0 matrix. An identity matrix, it is represented by I, capital I. What is an identity matrix? It's similar to 1 for the number system. If we multiply anything, any number by 1, what we are going to get is that number itself. Similarly, instead of 1 in the matrix system, it is unit matrix. Unit matrix is represented by, some more conditions are there. The unit matrix is a square matrix. What is a square matrix? You know what is a square matrix? If a matrix has the number of columns and number of rows are equivalent, that's equal number of rows and columns are there, we can call it as a square matrix. That means length and breadth, like that. Length and breadth, if it is same, then we call it a square, like that. If the number of rows and if the number of columns are equal, we can say it is a square matrix. The first condition for a matrix identity or unit matrix is that it should be a square matrix. Another one, the second one is that So it is the number of columns and number of rows are same, we know it. It can be a 2 by 2 matrix, a 3 by 3 matrix, a 4 by 3, 4 by 4 matrix, and so on. And so this one, the first condition is that this square matrix, another one, only the diagonal numbers. For example, I am going to write a 3 by 3 matrix, and only the diagonal numbers can have value. All the other members in the matrix is 0. See diagonal numbers, and here also it's 0, and then see this is 1 and this is 0, and this is the first row, this is the second row. Is it a square matrix? Not it. So one more row is necessary to make it a square matrix. So I am going to put 0 here and again 0 here, 1 here. So this is an identity matrix. See, it's a square matrix, and all the members except the diagonal ones are 0, and only the diagonal members are 1. And this is the identity. We call it the identity matrix or unit matrix. Okay. So now two conditions are there. The symbol is the next one. The symbol is I. For identity matrix, symbol is capital I, not small I. So we know that for a matrix to have inverse, all the matrices are not having inverse. Only first condition is also there. It should be a square matrix, or rather than the square matrix there is no inverse. So when we multiply 3 into 1, we will get 3 itself. Like that, a matrix A is taken. If we multiply A by A inverse, what we are going to get is I, the unit matrix. And this also can be A inverse into A also, because the order of the multiplication is very important. In the matrix, if only in this case it may be correct. You have already learned that A into B is not equal to, in some cases it is same, and most of the cases it is not the same. AB may not be equivalent to BA. So here the order of the matrices are very, very important. See, to eligible for multiplication, the number of columns in the first matrix must be equal to the number of rows in the second matrix. Then only we can multiply it. That is why I say the order of matrix is also important. Yes, sir, if there is an inverse inverse exists for the given matrix, then when we multiply A into A inverse, what we are going to get is a unit matrix like this. And then, in this case, it is also same. A inverse into A will also give I itself. Okay. And what is the, now you got, I think so, you got the importance of the inverse of a matrix, because there is no division in the matrix system. And now we have to learn to find the inverse of a matrix, the determinant. We should learn the determinant of a matrix. What is determinant? Okay, then we can proceed. Determinant means matrix is the array of numbers we know in rows and columns. Determinant means the value of the matrix. Okay. If it is the smallest determinant which we can take is a 2 by 2 matrix. Suppose A, B, C, D. A, B, the first row, C, D, the second row. I put it. This is a matrix. I can give it a name. P is equal to A, B, C, D. If you want to get the value of this matrix, we have to take the determinant. We call it determinant, or determinant P is equal to instead of this square bracket, we are just putting 2 lines. This means the determinant, the value A, B, C, D. And here, look, this value is, we are going to cross multiply. Starting from A, you should go diagonally to D. So this value is AD minus, next the other one from the reverse side, it should be taken AD minus BC. This is the value of this determinant. Okay, now If we want to take the, this is a small one, it's a, you see, 2 rows and 2 columns are there, it is a 2 by 2 matrix. If another one is given, yes, 3 by 3 matrix, determinant can be found out only for the square matrix. Otherwise, it's just an array of numbers of rows and columns. Okay, to find the value of a determinant, that is for a 3 by 3 matrix, what we can do, we can see. It's a, if I want to take, I'm going to write another one, let it be B is equal to, a matrix is taken, it's a 3, 4, -1. You can put a negative also, negative values also, so you will be proficient in that one. Okay, now the another one 2, 0, let it be 8. I'm just putting in the numbers, okay. It's the another one 2, just negative, okay, 1, -1, 4. This is the matrix. Now we want to find the determinant of this one. To find the determinant, what should we do? We know that this determinant, the value is AD minus BC, and here 3 rows and 3 columns are there. So what we should do? First we should take the first member 3. Okay. Then it's equal to 3 into, we have to take the minor, we call it minor of this member 3. Okay, so take 3 and then the row and column in which 3 is an element, we have to omit that one. Then what is remaining? That is the minor. So minor of these 3 is, this row and this column is excluded. The remaining is 0, 8, -1, 4. Okay, the next one. There are, cofactors, they are cofactor, the sign of each element is called the cofactor. I can tell you, it's this for 3, we have to put the signs also. The first one is considered to be positive, the second one negative, and then the third one positive. And similarly, here it is positive, this is negative, this is positive, and this is negative, so this must be positive, and here it must be negative. See, alternative ones, positive and negative, in the row wise, and it also in the column wise, it is coming like that. To get that one, another way is also there. I can explain it. Okay? Now we got 3 into, the minor is there. Next is 4. We know that the sign of 4 is, sign of 4 is negative. So the next one. So I put a -4 here, and now I am going to take the minor of these 4s, the element 4. So what should we do? We should, avoid the row and column in which 4 is a member. Okay, so I am just deleting this one and this one. What is remaining? 2, and we should not take this 0 because it is a member in the column 4. So 2, 8, 1, 4 is the minor for the member 4. So 2, 8, 1, 4. We know that the third one, this is positive, this is negative, the next one is positive. Alternative, maybe positive and negative is coming. And so it is plus, but already it is negative, isn't it? So I am putting this -1 here, plus this positive plus this negative will make it a negative. You know this. Now we are going to take the minor of this -1. So this one and this one is gone. The remaining is 2, 0, 1, -1. 2, 0, 1, -1. Now I think you know it how to calculate, because the ABCD we have already written here, the value is AD minus BC. Similarly, we can find these values also. 3 into 0 times 4 is 0, and then minus of -1 into 8. This minus with this, the other minus will make it positive. So we can do the calculation like that. Here it is 2 times 4, 8 minus 8. Here this is minus, then -2 minus 0, then multiply with this value for the value which is outside, then we will get the value of the determinant. Okay, I think No, now I can rub and then we can proceed. So value of this determinant is B is equal to what we are going to get is the determinant B, or we should put two lines before and after for this B. Okay, what we are going to get here, we can see is 3 into, now we can put the bracket 0 times 4. I put 0 here, minus minus 8 times negative 1, it is negative 8. So this negative into this negative becomes positive, so I put positive here. Then this 4 comes, minus 4 into, we can put bracket again, this 2 times 4 it is 8, 8 minus 8 times 1 it is 8 itself, okay. So 8 minus 8 it is 0, 0 times 4 it is 0 itself, that 10 is also cancelled. Then comes this plus with this negative, plus and minus, it becomes, we know it is one positive, one negative, we will make one negative. So it becomes negative 1 into 2 times this one, negative 1. We can put the bracket negative 2, then 1 times 0, it is 0 itself. What will be the value? We can see that is 0 times 0 plus 8, it is 8 itself. So 3 times 8, what is this value? Is 24. Then here we know that minus 4 into 0, it is 0 itself. 8 minus 8 is 0, so we can consider it 0. 4 times 0, it is 0 itself. Then negative 1 into this negative 2 minus 0 is negative 2 itself. So negative 1 into negative 2, it becomes positive 2, isn't it? Okay, so see, well, then what is the one we are going to get is 24 plus 2, it is 26. This is the value of the determinant for the matrix which is given as 3 4 81 2 0 8 1 81 4. Okay, this is how we are finding the determinant. If it is a 3 by 3 matrix, also it is easy to find. If it comes for higher order ones, that is 4 by 4 or 5 by 5, it's very difficult to find it. It's a complex calculation. So another method is, we can use like what we can use the calculator. There is in the computer, there is a calculator for the other calculator, like the other number calculator. There is also something for the matrices also. Otherwise, we can use that one. If it is 2 or 3 or at least 4 by 4, we can do something. It's okay. But in your syllabus, only up to 3 by 3 is there, so it doesn't matter. Okay, now I think what is determinant, you got it. Okay, identity matrix, you got it. And then zero matrix, you got it. Now we are going to study the inverse matrix. That is why we are studying the determinant. Okay, what is the need of an inverse? Can you say what is the need of an inverse? I have already told you. It's the need of an inverse is, okay, the need of an inverse, I have already told you that is we can't divide a matrix by another matrix or matrix, but what we can do is we can multiply. Also, we are taking the inverse and multiplying the first one, so we will get an identity matrix. And sometimes, like for example, I can tell you, I already told you, isn't it? In real life, if you are, suppose you got 20 sweets. If you want to divide it between two people, it's not allowed to by 2 people or 4 people, how many it may be, it doesn't matter. Okay, and we have already learned that a matrix cannot be divided by another matrix. It's like here, suppose a number is taken, that is 20 sweets are there, it should be divided between 4 people. So what we usually do is 20 will be divided by 4 and we will get the answer. It is 5 itself, isn't it? But here, if such a rule is that any number cannot be divided by another number, but it can be multiplied by another any number, then what we will do, instead of dividing by 4, we if you are wise, what you are going to do is you will take the reciprocal for this 4. uh, Reciprocal for 4 and will multiply the 20, multiply the first number by this reciprocal, then we will get the correct answer, isn't it? The same method is used here also in the inverse for matrices. Okay, so that part is clear, I think so. And then to get an matrix, we have to find the determinant. Determinant is the value of the matrix. It should not be, if it is a square matrix, we can find the determinant, otherwise it's not possible. Another thing you should understand that all the matrices, they don't have inverse. Only a few have inverses. The first condition is that the matrix which we consider must be a square matrix. Okay. Okay. Then now, the method in which, the way in which to find the inverse, there are 3 ways. The first, to find the augmented matrix. The augmented matrix is the matrix with the same order, identity matrix, and then we are going to manipulate the rows. Some rows are there, but the value of this determinant, value of that, the determinant for that matrix should not be changed also. We can do some manipulations for row. One row can be added to the another one. Then you can find, another and also subtracted from another one and put it in its own place. We can do that is manipulation. For example, I can tell you this is the first row. This first row can be added to the second row, and then we can replace this first row by that added number. For example, or we can subtract it also. What should we do? From the, I can show you, from the first row I am going to subtract the second row, and then that value should be substituted in the place of the first row itself. Then after that you calculate, you can test it by yourself. You see, when you find the determinant, you will see that the value is not changed. The value of the determinant is not yet changed. And then, but another option is there. I can tell you. See, if 3 minus 2, 3 minus 2 is 1, we can replace this 3 by 1, and then 4 minus 0, and then we can put in the place of this second member 4, and the negative 1 minus 8, that is negative 9, and then then the second row as such, we should write it as such. Then 1 minus 1, 4, and then this 1, if we find the determinant, it will be same as the previous one. Okay. How the value changes is that if we multiply, here what we do, once more I am telling you, here what we did is the first row R1, we can say R1, now it is changed to be R1 minus R2. The value will not change. When as the value change, if we multiply this R1 by a number, for example 3, and then it becomes 9, and then when you subtract from here and then you put the value, at this R1 is going to change to be 3 R1 minus R2. Then we can see, when we find the determinant, we will see that the value of the determinant will be multiplied by these 3 itself. You understand? It's that it means the value will be different. We can't do like that. If we want to manipulate, do something with the rows, then the number which we are going to substitute in the place of the row, the specified row, must be something from subtracted from some another row, must not be multiplied by some another number. Okay, then the value will be changed. And see, it can be 3, it can be R1, and then it cannot be 3 R1 or 4 R1, then the value will be changed. Then R1 minus R2, then we will get a value. We are going to put in the corresponding places for R1, then R1 is changed. Okay, you should try it and then find the determinant and find it whether the value is changed or not. Okay, You should not believe what I am saying. Huh? What you should do it by yourself. Okay, and then confirm it. Okay, now you got it. I think so. Okay, or our aim is to find the inverse of a matrix. So first we want to find the determinant. That is one minute. Now we have to find the determinant. We got it. We should find the minor for each and every one, and we should put it there, isn't it? Now the correspondingly. For in here we have found, we found out only the value for the determinant. Now we are going to find the cofactor matrix. Cofactor matrix can be found out in the same way we have to, which we have done. Each and every member should be taken, and then its minor should be taken. Now, how can we find the minor? The particular the number we took, particular member of the matrix we took, we should avoid all the members of the rows and columns in which this particular number is a member, and then take the rest of the array of numbers as a determinant. That is the minor for that particular member. Okay, did you understand that? Like the way in which we have find the determinant for this B. Okay, for each and every member, the minor should be calculated and then make it as a another matrix. Okay, now what should we do is we should add the cofactor also. To find the cofactors, that means just think that we should include the sign also. Then what we are going to get, with the determinant, we will get the cofactor matrix. Then to get the inverse, just to take the transpose of this cofactor matrix. What do you mean by the transpose? We should interchange the rows and columns. Then what type of matrix we are getting? It is called the transpose of the matrix. So we have to find the cofactor matrix, and then we have to find the transpose. Then to get the inverse, we have to take the transpose and then divide the whole matrix by what? The determinant value. Then we will get the determinant value here, it is 26. So divide it by 26. And to just dividing it by a number, we should divide each and every member of the matrix by 26. You should not confuse the by one thing. I told you matrix should not be divided by another matrix, but it can be divided by a number. It is allowed, and also it can be multiplied by a number. It's also allowed, but matrix should not be divided by another matrix. That's all. Okay. Yeah, I'm giving you one tip. You should remember it for the next class. A inverse can be found out by A inverse is equal to first adjoint of matrix A divided by determinant of A matrix A. Okay, how can we find the adjoint of the matrix? To find the adjoint of the matrix, we should find it is the transpose of the adjoint matrix. Is the transpose of the transpose matrix of the cofactor matrix. Transpose matrix of the cofactor matrix. Cofactor matrix, how to find the cofactor matrix? That is what I told you. It's in okay. So you should write this also. To put cofactor matrix Cij. I means the number of rows and J the number of columns. So a matrix with Cij, a matrix with the number of columns, we are representing the number of columns and also the number of rows in this way. C with the suffix ij. Okay, this is C represents the four-factor matrix is equal to minus 1 raised to ij. This is how the sign comes. Cij into, then we know it, isn't it? Then the four-factor matrix Cij is equal to, then we have to find the minor and then to find the value for each and one. Cij into minor. Okay. 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 Now this lesson I am going to wind up, and then next, I will upload the next lesson, within 1 hour. Oh, so that you can pop up, you can do the, okay, you can revise it, and then the next day, that is tomorrow, we should go through the next lesson. Then I will upload it. Okay, within 1 hour. Okay, thank you.